Prove theorem 7.3.2b. If f is a function from x to y, is a one-to-one and onto function with inverse function f inverse from y to x, then f of f inverse equals the identity function on y, where y is the identity function on y. So theorem 7.3.2b says that if f from x to y is a one-to-one function and onto function with inverse function f inverse from y to x, then part B says f of f inverse equals I sub y. So our goal in this problem is to prove that these two functions are the same function. Now, both of these functions have the same domain. If you notice here, the first function in this chain of functions in this function composition is f inverse, and f inverse starts from y. Similarly, I sub y is the identity function on y. So in both cases, the domain of each function is the set y. What we need to show is that if we plug in any element from that set y, we get the same output whether we plug it into the identity function or whether we plug it into this composition here. That's the goal of this proof. Now that's a lot easier said than done. What we're going to do is we're going to start with an element in capital Y, which we'll call lowercase y. Now if we plug y into the identity function, we just get y. Our goal is to show that if we plug this same element into the other function, we get the same output, which should be y. Now, what I see a lot of people do in this proof is they'll say f of f inverse of y equals y because these are inverse functions and those just cancel. But this is circular reasoning. We have to show that this is true. This is not something that we can just assume. This is the whole thing that we need to justify in order to show that these two functions are the same. And we're not allowed to assume the conclusion in order to prove the conclusion here. So we're going to approach this very differently. Notice, by the way, that f is one-to-one and onto. Now, we're just going to use the property that f is onto here. Since y is an element of y, and f is a function from x to y, that means y is an element of the codomain of f. Since f is onto, that means every element of the codomain is an output of the function. So then that means that there exists an element in the domain of the function, capital X, such that f of x equals y. Now, since f of x equals y, that also means that f inverse of y equals x. That's super relevant here because notice how x is an element of capital X, and x also equals f inverse of y. That also means then that f inverse of y is an element of the domain of f, which is capital X. If f inverse of y is in x, that means that we can plug this element into the function f. This means that f of f inverse of y equals f of x. Now the reason this is important is because f of x equals y. And this is the proof that f of f inverse of y equals y. And so when you plug in an element into this composition, you get the same output as if you plug that element into the identity function, which means that both of these functions are the same functions for every element in y, and the domain of both of these functions is the set y. And so these two functions must be the same functions. I really want to emphasize that this proof required the property that f is onto here. Without this property, it would have been impossible to find this element x here. Thanks everyone, and I'll see you in the next video.